if we look at the series 1 over n to the p, and here we're going to assume that p is bigger than 0, and from 1 to infinity. And then if we can look at the corresponding function 1 over x to the p, and when x greater or equal than 1, then f of x is going to be positive, and f of x is going to be decreasing. So we're allowed to do the integral test here. So for the series 1 over n to the p, we can switch to the integral 1 to infinity 1 over x to p dx, because we're allowed to do the integral test. Antiderivative, straightforward to find, is going to be, we're going to write on x to a negative p, integral 1 to infinity dx. So we're going to get x to negative p plus 1 divided by negative p plus 1, and we're doing it from 1 to infinity. So we're going to rewrite it as 1 minus p to the power x to p minus 1, 1 to infinity. So we substitute the upper bound, substitute the lower bound. So we're going to get 1 over 1 minus p infinity to p minus 1 minus, substituting 1, we get 1 minus p 1 to the p minus 1. So you see, everything depends on what is going on with this guy. So what is going on here? So what is going on here? So if p minus 1 is bigger than 0, and then they have infinity to positive power in the exponent, so then we're going to get 1 divided by infinity and some coefficient here, so we're going to get 0. On the other side, if p minus 1 is less than 0, we're going to get power of infinity is going to be negative, and negative in the denominator would mean we'll move it to the numerator of positive. So we're going to get infinity to positive here divided by number. So we're going to get infinity. So what is our conclusion is that integral 1 to infinity 1 over x to p dx is going to be equal to, look at infinity here, infinity, if p minus 1 less than 0, and you're going to get 0 here when p minus 1 less, but p minus 1 bigger than 0, so it's going to be convergent if p minus 1 bigger than 0. So that's what we got. Don't forget we have some extra coefficient here. So we have integral 1 to infinity 1 over x to p dx is going to be convergent if p bigger than 1. Infinity means divergent. Divergent if p is going to be less than 1. We already did an example a minute ago. Then we considered integral 1 to infinity 1 over x dx. That is ln of x. X from 1 to infinity, we know that's infinity. So when p equals to 1, which is this case, it's going to be divergent. So when p less or equal than 1. So that's our thing which we noticed about the integral. Because we're allowed to use the integral test, so from series we switch to integral, and because we're allowed to use the integral test, we can do the same conclusion about the series. So that is so-called the p-test. So I'm going to call it p-test. So we have series 1 over n to the p n from 1 to infinity, then the series is going to be convergent when corresponding integral is convergent, which is right here. So convergent when p bigger than 1, and it's going to be divergent when corresponding integral is divergent, that is when p less or equal than 1. So that is p test. So that is p test. So that's a p test. Let me quickly do an example on it. If I look at the series 1 over n squared and from 1 to infinity, and I want to know it's convergent or divergent, I notice that p equals to 2. So I immediately conclude that by p test, because p equals to 2 bigger than 1, convergent. So our series 1 over n squared and from 1 to infinity is convergent. Second example, if I look at the series 1 over cubic root of n and from 1 to infinity, and same question, I want to know is whenever it converges to divergent, I notice that p equals to 1/3, because you remember cube means n to 1/3. So here by p test, p equals to 1/3 less or equal to 1. So it's in situation right there. So we conclude by p test, because p equals to 1/3 less or equal than 1, corresponding series, which is cubic root of n and from 1 to infinity, is divergent. Say the third example, if I have n from 1 to infinity, 1 over n squared square root of n, that is p series, p equals to n squared and square root of n, so the total power is going to be 5/2, bigger than 1, so we conclude by p test, p equals to 5/2 bigger than 1, so the corresponding series n from 1 to infinity 1 over n squared square root of n is convergent. So that's how approximately we're going to be doing our p test.